Hello everyone, I am Dr. Sirajul Akfaisi. I welcome you in my YouTube channel. Today in this video, we are going to learn about molecular orbital. What is molecular orbital theory? Molecular orbital, it is a space around the nuclei of molecules where the probability of finding electron is maximum. Now, silent feature of molecular orbital. Molecular orbital gives the electron probability distribution around a groups of nuclei, just as an atomic orbital gives the electron probability distribution around the single molecules. Now, the second important silent feature of molecular orbital theory, when two atomic orbitals of equal comparable energies combine or overlap, they lose their identity and form two new molecular orbitals. The two new molecular orbitals are bonding molecular orbitals and anti-bonding molecular orbitals. Bonding molecular orbital has less energy, more stable and denoted by sigma on pi and delta, whereas anti-bonding molecular orbital has more energy, less stable and denoted by sigma star, pi star and delta star. Follows the same rules of filling electrons as that of atomic orbital. Atomic orbital with proper orientation can overlap, combine. For example, 1s can combine with 1s and not with the 2s. Similarly, s character combine with the pz but not with the px and py, or pz cannot with the px or py, taking z axis as an INA. So my friends, conditions for linear combination of atomic orbitals. We call it LCAO. LCAO, L for linear, C for combinations, A for atomic, and O for orbitals. The combining atomic orbitals should have comparable energies, that is, 1s combined with the 1s, 2s with 2s, and 2p with 2p. The combining atomic orbitals should have the proper orientation, same symmetry, that is, 2pz can combine with 2pz, or 2s but not with the 2px or 2py. The extent of overlapping should be maximum to give a stronger bond. My friend, formation of molecular orbital. So I will talk case 1, when the two waves are in the phase constructive inference so that they add up and amplitude of the new wave is phi is equal to psi A plus psi B. So psi A and psi B, two wave additions, it gives psi A plus psi B. So additive effect of the electrons wave in phase. Now friends, case 2. When the two waves are out of phase, destructive interference, the waves are subtracted from each other so that the amplitude of the new wave is phi prime is equal to psi A minus psi B. You can say psi A and psi B after subtraction psi A minus psi B. Subtractive effect of the electrons wave out of phase. So, molecular orbital. These two new orbitals have different energy, 1s, bonding sigma 1s and anti-bonding sigma star 1s, and this is the energy level. So, in anti-bonding there is a node. Now, sigma 2pz, sigma 2p and sigma star 2p, molecular orbital. In pi, 2py and 2py or 2px, 2pv, pi 2p, pi 2p star, and pi 2p and pi 2p stars. So, characteristic of molecular orbitals. Electronic configuration sigma 1s, sigma star 1s, sigma 2s, sigma star 2s, pi 2px is equal to pi 2py, sigma 2pz, and pi star 2px is equal to pi star 2py, sigma star 2pz. Stability of molecules in terms of bond order. Bond order is defined as half of difference between the number of electrons present in the bonding and anti-bonding molecular orbital. That is, bond order is equal to half in V minus N. Now friends, greater the bond order, shorter is the bond length. In the fourth important characteristic properties of molecular orbital is diamagnetic and paramagnetic nature of molecules. If all the electrons in the molecules are paired, it is diamagnetic in nature. On the other hand, if the molecule has same unpaired electron, it is paramagnetic in nature. So magnetic moment is equal to Nn plus 2 Bohr magnetons, Bm, B for Bohr and M for magneton. So you can see here atomic orbital, and in between molecular orbital. So sigma 1s, sigma star 1s, sigma 2s, sigma star 2s, pi 2px, pi 2py, and sigma 2pz, pi star 2px, pi star 2py, and sigma star 2pz. So electronic configurations from O2 and above, this graph will follow: sigma 1s, sigma star 1s, sigma 2s, sigma star 2s, sigma 2pz, pi 2px, pi 2py, pi star 2px, pi star 2py, and sigma star 2pz. So this is the order of electronic configurations from O2. So friends, now I will talk about hydrogen bonding, and then I will finish. What is the hydrogen bonding? When a hydrogen atom linked to a highly electronegative atom like fluorine, oxygen and nitrogen comes under the influence of another strongly electronegative atom, then weak bond is developed between them. This type of bond is called hydrogen bond and is represented by a dotted line as shown below. You can see HF, hydrogen bonds, and in water and alcohol, you can see how it is forming hydrogen bond between hydrogen and oxygen. The greater is the electronegativity difference, more is the polarizations of the bond of the molecule. The smaller the size of electronegative atom, more is the electronegative attractions. So, types of hydrogen bonds: intramolecular hydrogen bonding and intramolecular hydrogen bonding. Intermolecular hydrogen bonding means when hydrogen bonding takes place between various molecules of same or different compound is called intermolecular hydrogen bonding. For example, you can see here water. They are forming hydrogen bonding, and you can see also vacant space, cage-like structure of water in the ice. And see the distance 0.99 angstrom and hydrogen bonding 1.77 angstrom. They show abnormally high melting and boiling points. My friends, intramolecular hydrogen bonding, when hydrogen bonding occurs within the same molecule, is termed as intramolecular hydrogen bonding. Intramolecular hydrogen bonding you can see in orthonitrophenol and salicylic acid and orthonitrobenzoic acid. In all these three molecules, there is a oxygen and hydrogen belongs to same molecule. So it is called intramolecular hydrogen bonding. So my friends, I hope this video will be helpful to you. If you like this video, then subscribe my channel, and thanks for watching.